just kind of a little overview of our presentation is I'm just going to provide a little bit of update of some things that are going on in the lab, and then some general trends that we're seeing related to PDV and PRRS really at a national level, and then turn it over to Pablo, and then he's going to get, and Pablo is a diagnostician within our group, a diagnostic pathologist, and then he's going to share some updates and trends and so on in our overall caseload and the types of cases that are being seen at the diagnostic lab. And I just provided a few introductory slides here just for some background of in case you don't know, just a little bit about kind of who we are at the lab and what we do. So we're housed at the College of Veterinary Medicine. They're in Ames, okay? And like Chris said, our team now is we're a team of about 145 people. We got about 25 faculty and about 120 technical staff. And then we have the folks, we're kind of divided up within the lab in these different sections, so people that have different skills in all of the different, I guess I could just call them diagnosticologies. And really what our primary focus of what our team tries to do and be is really one of the preeminent food animal veterinary diagnostics labs in the country. So that our core emphasis is serving food animal agriculture. And our direct clients are the practicing veterinarians. Okay, and so we serve the veterinarians who then in turn are working directly for the producers. And this is kind of what our world looks like each day. Like Chris said, we process something over about 75 to 80,000 cases a year, and try to do that most efficiently and accurately as best we can. And really, it's our service model that drives our teaching and research as well. Okay, so this volume of cases that's coming in and our service for the veterinarians is really what in turn we use that material for teaching, and it really drives our applied research program. And where we're somewhat unique amongst our peers and how it maybe relates to this particular meeting is that we do an awful lot of swine work. Okay, so at the lab now we're something that's just north, I would say, of 75 to almost 80% of the work we do is related to pigs and pork producers, and then the other 10% are bovine, other 10% poultry, and then about 5% of all other God's creatures. And our cases, as far as where they're coming from, if you look at this map and the distribution of that cases, what you will find is the distribution of that looks a lot like that. Okay, and so because we're getting these cases really from all over the country because of these really tremendous systems of logistics that we enjoy, the caseload that we see at the lab is really a pretty good representation of kind of what's happening, in the U.S. pork industry. Probably you may hear of this in the next year or 2 years, 3 years, we'll see, is a major effort going on at the college and at the lab is an effort to essentially build an updated facility. Okay, so today the lab that we're in was built in the mid-'70s. Okay, so it had been planned for in like the early '70s, '72, '73, and was populated in '75, '76. Okay, and it's actually housed, we're actually within the vet med building, so actually we're just adjacent to the working food animal hospital and so on, and that creates its own set of challenges. And probably just a basic overview of the project is looking at a new standalone facility to get us from a biocontainment to get us away from the hospital, okay, because today is essentially we're in the same building like across the hall from the hospital, and animals coming in and out, and we got all this sick stuff coming in, and so it would be building a standalone facility that would give us a bit more square feet, from about 60 to 80,000 square feet, and then they would repurpose what we would move out of for both teaching and research purposes. And it's a very large capital project. Okay, the scope of it is about $124 million project, and it's a big undertaking for certain for the state of Iowa and Iowa State University. In fact, as a standalone project, it's actually the largest non-athletic facility project in Iowa State's history. So no short undertaking. And probably this, I think, picture represents the best depiction of why do we need a new lab and all that. It's how we're going through this. So this is what the VDL looked like in 1974 when the folks moved into the lab, with a team of about 10 faculty and then about 20 staff.
And really, essentially, we're in the same space and shell that these folks moved into, and now we look like that, okay? And you can imagine what, if you think about agriculture, what it looked like in the mid-1970s. It's a quite different world that we're serving, and so this is just kind of a progression to keep up from an infrastructure standpoint. Another thing that we've had a lot of focus on at the lab, as it relates is really enhancing the quality and the connectivity of our record. And it's really been about a transition to transition our systems from more what I would call more conventional paper-based systems to make our records and incoming and outgoing information much more fit for the digital era, okay? And there's a lot about that is not only for day-to-day management and purposes, but a lot of it also is as we think about preparing and for responses for emerging, re-emerging and emerging diseases or foreign animal disease responses and things like that, okay? Because as you all well know, is one thing that happens an awful lot in today's pigs world is there's an awful lot of pigs that move, right? So just for some scope of that, there's something like just north of 525,000 pigs a week that move into the state every week. That's happening. You think about what that's like 500 almost individual 1,000-head finishing barns every week being populated from outside the state. So a lot of things moving, and so this has been a big area of focus. And it was one of the key things that we took away. The lab, we were right in front and center in the middle of the high path thing. This was in 2015, okay, so not this past year, but the year before that. And as we went through then kind of did some retrospective look at that, one of the biggest things we felt at the laboratory anyway for our role in support of that is, we had good people, we had good systems, we had quality tests, this, that, and the other. But the biggest challenge was the content and the quality of the record, okay? The traceability of the record and its really its fitness for the digital era, because the information that was being received wasn't necessarily complete, okay, and it wasn't consistent and so on. And so this has kind of been the primary thing that we've observed through that experience, and then kind of our predecessor as we went through the PDV thing is that as we've gotten into this digital age, what we find is that these manually entered premises level information, so things about the farm site itself, they're really not compatible with any sort of web-based application. And the primary difference is because you don't have you don't have the consistency of the information. So if somebody terms it a little different, or there's an extra space, or it's a capital versus a tire, it's a number, and as you guys know, the big thing in the traceability for the premises is these premises ID numbers, okay? And they're a 7-digit alphanumeric number, okay? And they are a total disaster to be able to try to transcribe. And so really transitioning to digital is important. And the other thing that we've learned in going through these things, and we participate in a fair bit of these, like drills and so on for foreign animal disease preparedness is what this is. And I think from our experiences that true preparedness is what we do every day. Because in the end, that's what you rely on when you're faced with a crisis. You just can't all of a sudden, now we're going to do it different. We don't believe that's true. And so we're really trying to work with our clients very closely and build our systems to be better prepared. And one of the big things around that has been is transition through going through the process of transitioning our systems and clientele over from paper-based submissions to web-based submissions, okay, or receiving our information electronically from our clients as opposed to on conventional paper forms. And so there's been an awful lot of work in developing new tools to be able to do that through the web, through electronic, and it's really been a significant emphasis. And this just kind of shows you what that looks like as far as what has been the uptake since we really started to launch this stuff in 2015. We've really seen a rapid increase, almost about a tenfold increase over that last year and a half. And we're continuing to try to incent as we make our tools better, so it makes it easier for the submitters, okay, and that also that there'll be some financial incentive for best practices, okay, and so we would look for that to continue in the coming year. And this is really what it looks like when they fill it out online, and then they can print off the form and include it, and this is the premises ID, okay, because everybody has their own libraries of owners and sites, and so it prints the barcode prem ID on the sample. And really what we need at the lab to accompany the sample is really just this web ID number, okay? And then we just type in that number and it pulls up all the information from what the submitter had submitted online. Okay, and we also have something that we call an e-form, and that's for situations where, you know, this web thing just isn't going to work for me because I don't have all the information in front of me that I need to fill out the total form. And so we have these e-forms where it basically is the people generate all the farm level information on the web. They print this out, and then they fill in the additional information about the farm, the samples themselves and so on the farm. And but again, we capture the benefit of being able to capture that electronically. Another thing kind of in this same vein is we've just recently launched this was a new tool that we call our daily summary report. And so every day we send out an email to every client and so any case that a client is associated or affiliated with, any active case, it gives them basically a brief synopsis of the case, okay, of where it was from, what are the results, that kind of thing. And then it provides them a hyperlink, okay, this is what it looks like on their phone. They can press that hyperlink, and then what that does is that opens the whole case so they can see the whole case report. And we have a thing that we call a forward link, and they can just click on that, and it takes them right to their email on their mobile device, and then they can forward that around to their producers or whoever that they want to share that case report with and add any commentary that they wish, okay? And when it forwards that, it forwards it with this secured hyperlink, okay? And so the person getting that email, then they can just click on that, and it pulls them right into the report, okay? And then just some other things with our conventional web portal we've added some things there where now that the clients can manage all their own preferences, things that tell us about who are the veterinarians in their practice, what's their contact information, what are their reporting preferences about how often and when they want to get their data, and some tools again to email who they want to. And then another thing, if they wanted, because a lot of times what happens in our world is they'll submit some tests, we do those, and they say, oh, well, now I want to do a little bit more. What about this? What about that? And so now they can submit those additional requests online. And a thing we're currently working on that we'll be launching here in 2017 is a more mobile-friendly version of our web portal. And so we're looking forward to that here in this coming year. And another thing kind of in the same vein around FAD preparedness and so on is we've been going through, you may have heard of something that's called the Swine Health Information Management Center. Okay, and so a cooperative project funded by that group and the USDA is a project really to standardize all of our swine diagnostic information. So when it comes from all the different labs, okay, because today we live in this world as we go back and forth between our clients, okay, and that works out really well. Okay, but when you want to send that information to any sort of third party, when it comes from the various labs in today's world, it all looks different. Okay, and so there's a big effort to say, how do we use standardized codes and so on? So when we send it to third parties, it all looks the same. And again, really, it's all about making this data fit for the modern era of digital. And this is really what the system looks like for our country. For the U.S. National Animal Health Disease Network, is we're working here with our clients, but then for program disease responses, we have to push that information to the USDA, and a key part of that is sending them in these standardized messages. So again, enhancing our preparedness for program disease response. Okay, and this effort, I kind of liken it to this, is that I use the interstate analogy because it's really what we're doing. This is really an infrastructure development project around how we manage information. And one such example of that, moving now into kind of disease trends, what this is a graph that depicts all the PDV cases that are being diagnosed from all the labs across the U.S. Okay, and so this is for the very first time. Because associated with this reporting and some of these messages being sent is the data is coming in, from all the labs. It's getting messaged. It's going to this thing called through the USDA, and then is being forwarded to this program called web-based thing at Davis called BioPortal, and provides basically like a dashboard. Okay, and so what that means to us and you is says, okay, as you guys can see, this was the first outbreak there in that winter of 13, spring of 14. A little bit of a resurgence every winter, okay, and then this is where we are, okay? So you can see, as a whole, it's been much, much less this year thus far than in the previous 2 years, or 3 years, excuse me, since PDV first came. And with tools like this, is you cannot see to say, well, yeah, that's great, that's what it looks like overall, but what does it look like in my world, where I live, right, where my farms are at, and so on. And so with this tool is you can also say, look at it and say, what's going on in each state, okay? And this is really what that looks like. So what these graphs show is what it looks like by the 4 major hog production states of Iowa, Illinois, North Carolina, and Minnesota, okay? And what you can see in all of these, it's really quite interesting, is the Iowa graphs tend to look just like the national scene, okay? And when you think about it, that really probably makes sense, is because like the Iowa industry is, you know, kind of like we're like the cultural melting point, right? Because we're receiving all these pigs from all over and so on. And so our graphs look very much like the national averages. But what you can see by different regions, some based on location and some based on composition of the pork industry in those respective states, it can be quite different, okay? So you can see here, Illinois, they really, you know, once they kind of got over that initial hump at a little bit seasonally, and then the last year have seen very, very, very little, right, PDV. And you can see the Carolinas is more of a farrow to finish industry, and they really, and it's very dense down there, and they had a real struggle in the 2 years past the break, but now this past year have really seen much, much less. And the Minnesota experience would be much more resembled to date, more similar to Illinois. Okay, and although we don't have a common repository like for reporting for PRRS like we do for PDV, okay, this is probably the closest thing that we have. And this is a graph that some of you may see and get this report, is a graph that Minnesota distributes every week, right? And so they have a large group of producers that are reporting their PRRS statuses each week to them, and basically reporting PRRS breaks, okay? And so that's what you can see, these humps, okay? Every time it's getting cold, we're having more PRRS, okay? And what you see now is this year, okay, we're kind of, and of course it's been a mild winter, right? We all know that. I've enjoyed that, but here just these last probably 3 or 4 weeks have definitely seen a pretty significant spike in the number of breaks being reported through this network. And unlike PDV, okay, I would say, and this is what this graph represents, is this is the status of the sow farm. So these green are negative, these light green are going negative, and down to the reds are positive, unstable, okay? And what you can see, this goes back to 2009, okay? And at least by the folks, you know, participating in this, which is a large segment of sows, a very good representation, you could argue that really there hasn't been a lot of significant change, okay? So unlike PDV, where we've seen really significant progress in reduction of disease since it was introduced, as it relates to PRRS, continues to be a fairly steady challenge. Okay, and what these graphs, what I'm trying to do here is to say, okay, that's just what this is for the Minnesota is kind of overall incidents and breaks being reported and this kind of thing. And what these graphs do is sometimes we'll use these things, and it's not the best way to categorize them by any stretch of the imagination, but it's something to kind of call them something. A lot of times we use these things, these called RFLPs, patterns, to say, well, what viruses are most prevalent? Okay? And I think probably the most significant thing to take away from this is look at these yellow bars. All right? This yellow bar here, okay, is something that's called a 174, okay? And then you look at these orange bars, okay, called 144. And then there's something called just this from this past year called 134. And these 134s are really intermixed a lot with these 144s. Okay? But what you see happening is that you have, and I'll go to this one here in just a minute, but you have a couple major virus groupings that are really taking over. Okay? And so this is this same graph as this, just broken out by month. And the reason I want to share that is because the precedence that this 174, and many of you probably have heard about that or experienced, unfortunately, is that you have a few of these very highly virulent strains that have become dominant. Okay? And they become, I would say, as if you look at it in the context of time, we don't really have many past examples where we've had such a grouping that is accounted for such a large percentage of the PRRS viruses that are being sequenced, okay? And this is kind of what it looks like by state, okay? And our data for this would be at best, so we said the same 4 hog production state. Our data for Minnesota isn't so good because we don't get as many samples from Minnesota, okay? This is just Iowa State data. The other data I showed you was the whole country's data. This is just our data, okay? But we do the majority of the diagnostics for Illinois and North Carolina as well, so good data for that and Iowa. And you can see is just you have these really, which basically are these 2 groups, these 2 clusters, what I call cluster 1 here, the 174, largely 174 cluster, and then this cluster 2, which is this 144 and now 134s, but they're basically the same variants of one another, but have really become quite dominant. And I think, you know, what makes sense is as we're going on with PRRS more and more over time, is that the strong survive, right? And they're out-competing the less virulent ones, okay? And so for sure the PRRS we have today is by no stretch any less virulent than we had 10 to 15 years ago. If anything, you might say it's getting, the viruses we have that are becoming dominant are becoming more virulent. Okay, so with that, I'm going to turn it over to Pablo, okay, and we'll go from there. Thank you, and we'll just take questions at the end. Thanks.
All right, thank you, Rodger. Our next presenter this afternoon is Dr. Pablo Pineyro. Dr. Pineyro received his doctorate of veterinary medicine from the Universidad Nacional de La Plata in 1999. He's also received his master's of veterinary medicine from Washington State University. Dr. Pineyro's primary research focus is the diagnostic assay development and basic pathogenesis of viral infectious diseases that affect our swine industry today. His current projects include PEDV, host pathogen interaction, and development of diagnostic assays and pathogenesis for Seneca Virus A. Dr. Pineyro has previous and ongoing collaborative projects on porcine circovirus type 1, porcine circovirus type 2, and PRRS as well. Please help me welcome Dr. Pablo Pineyro.
Thank you, everyone. Thank you for the invitation. Actually, I would like to add to the list. Now we have PCV3 among us, so we are also working with PCV3, so it's kind of fun. So what I'll do this afternoon, I'll try to share with you some of the trends in diagnostic cases that we have at Iowa State Diagnostic Lab. My main function in the lab is pathology diagnostician, so I get to see quite a few cases, and this is what I'd like to share with you in the first part of my talk, and second, give you some new diseases that we are working on, or new cases that we see through diagnostic investigation. So just to give you a context where we are based on the caseload that we have, and this is a breakthrough system. So where are the most important diseases that we normally see affecting pigs today? So this is just a summary for the last 2-3 years, 2013, 2015. So almost 50% of the cases that we see still being respiratory cases that affect swine production system, followed by enteric diseases, 30%, and systemic diseases, 20% of them. Then the rest of the small proportion goes through reproductive, CNS, arthritis, heart. So, but basically the most three important system that we've seen affected in swine production is respiratory, enteric, and systemic. And those are the ones that I would like to share some information with you. So respiratory diseases, there are quite a few, but I'm going to focus in PRRS and one new disease that we are working currently in the diagnostic lab. So when we look at the distribution of pathogens that we normally see in enteric case, in respiratory cases, so PRRS is still being the most prevalent. Look at here. It's 40% of the cases that we get through the diagnostic lab that are associated with respiratory problems have somehow PRRS. PRRS by itself, PRRS associated with other pathogens, but PRRS is a main cause of respiratory problems, followed by swine influenza, which is more a seasonal pattern, but we still see swine influenza, mycoplasma pneumonia, which is affecting one specific production stage, mostly at the end of the grower-finisher stage, but we still see cases of Mycoplasma having pneumonia, Posterior Multocida, Strep suis, and other bacteria are also associated with respiratory cases. But this is a percentage type of deal, so I'd like you to see what this means in real case number. When we go through the cases that are codified as a bronchointerstitial pneumonia, which means a viral disease that only has PRRS detected. This is the number of cases that we get a year. It's about 2,000 cases, PRRS by itself, PRRS with nothing else. So if we start adding co-infection factors, so these numbers can go way higher. So it means that even with all the management system that we have today, the vaccine that we can apply, PRRS is still quite prevalent and quite important for swine production. So how do we do the diagnosis? And I like to start with a really, really basic presentation. So we still rely on the clinical diagnosis. So we got a phone call, with an outbreak of respiratory disease, with these kind of bluish pigs that have distress, that they can breathe. So it's the first suspicion that we are dealing with PRRS. We rely also in the gross pathology. Diagnosticians in the field, clinical veterinarians, they can describe this lesion, and when we see these non-collapsing lungs, it's another indication that we are dealing at least with a viral infection. Later on, we can do histology. The histology, this is a typical pneumonic pattern associated with PRRS, and here is when we start putting all together. In this picture, we have an staining of the virus. So these brown dots in here is our cells, pneumocyte pulmonary cells that are infected with PRRS. So these are the very basic steps that we take to make the diagnosis. But in this new world, probably this is not enough. Clinicians need more information, not only to tell them, yeah, you had a pneumonia caused by PRRS. They need more. And that is when we start doing more analysis. And this kind of follow what Dr. May was saying. Sometimes people want to know, what strain do I have? I have the more pathogenic, the less pathogenic. What is causing the disease in my farm? So this is a break of the most common strains that we normally see, observed, analyzed by this RFPL analysis. So historically, the blue bars here were the 134 pattern that Dr. May was describing. This was the historical strain that we've seen associated with PRRS cases. Lately, this has been changing, and we see more and more 174 strains. So this is the type of information that we need to provide, that clinicians need to fight with the disease that they're in the field. But sometimes this is not even enough, and they need more. And the more means sequencing of the virus. So we have vaccines, and sometimes it's difficult to differentiate. What I have is a vaccine virus or it's a wild type. It's a bad one that causes the disease. So they need this piece of information just to make a decision based on what they have. So in the lab, we got a lot of requests, and after we get the diagnosis, so can we sequence? Can you tell me what it is? So this is what they basically get. It's all these random letters, and they get the percentage of identity with the vaccine or wild-type strains. And even with that information, sometimes we need to go further because this information doesn't allow me, if I have pigs that were treated, they were vaccinated with modified live vaccine, this information is not enough to differentiate the wild type. So now we are getting into a new generation and something more in depth. It's called NGS or next generation sequence, where we can do a full-length sequence, so we can sequence the whole virus. And if there are multiple viruses in the sample, we are able to tell how many there are and who they are. So this is probably the most in-depth diagnosis that we can get for practitioners out in the field. Now, switching gears to the other disease, the other respiratory disease that I mentioned at the beginning. And if you remember, I put a question mark. Why? Because parainfluenza has been described in humans for years and can go from mild rhinitis, this common cold symptom that we see, to severe pneumonia. What we see now that we have these coughing pigs that don't get any other diagnosis, and Dr. Geiger in Iowa State, associated with people in Kansas, they found this virus, the parainfluenza virus that normally have seen in humans, now is affecting pigs. So the main question in this case is if this virus is the primary thing, the primary pathogen, or it's just a secondary thing that is that we, based in the new technology, we can discover. So this is what we normally see in these cases. This is a section of the nasal cavity. So this is erosion of the mucosa. This is the trachea. Again, erosion of the trachea. So all that irritation of the nasal cavity and trachea is causing this coughing and sneezing. So, and this is more the definitive diagnosis. The brown staining here means those cells are infected with this virus. Here there's not much cell left, so that is why we have just 1 or 2 positive cells. So this is the first diagnosis of parainfluenza in pigs. We went a little further and we tried to see how widespread is this pathogen in the field. So this is a survey that we did in our lab. So these bars here, we got the total number of cases per state. So the first bar is Iowa State, North Carolina, Illinois, and so on. But the 3 most prevalent states are Iowa, North Carolina, and Illinois. The blue portion is the negative cases, and the red portion is the positive number of cases that we've seen associated with parainfluenza. And up here, this line is the percentage of positive cases. So Iowa, 33%, North Carolina, 44%, and Illinois probably, with the set of samples that we have, is the most prevalent state having parainfluenza virus. We went a little further. We want to learn exactly where in the production system is this virus affecting. And we got suckling pigs, nursery, grower, and adults. The blue bar is the number of total tests that we did per group. And this is the red bar are the positive number of animals. If we look at that in percentage, so nursery pigs and grower finisher probably is the stage where the virus is more prevalent. Saying that, the clinical association is not totally related, but at this point we can say that the virus circulating in this population is quite high. Now we're going to switch gears. Remember that I told you the first cause of health problem in pigs was respiratory, followed by enteric diseases. So a lot has been said about PDB. Dr. May mentioned what is the statistic of PDB in the state, but I wanna you pay attention of this pathogen, Salmonella. So we've been dealing with Salmonella forever, pretty much, but where we currently are about Salmonella. So this is a breakthrough of the enteric cases in pigs over 6 weeks of age. So if you look at here, Salmonella is the most prevalent pathogen that we recover associated with enteric cases, followed by Lawsonia, hemolytic E. coli, rotavirus, TCE, and other pathogens. So Salmonella is still really high prevalent in grower finisher pigs. We're going to look at enteric diseases. You may think that rotavirus and E. coli probably will be the most prevalent, but not. The difference is here. Salmonella is the second cause of enteric diseases in pigs less than 3 sorry, she said 3 weeks up there. My mistake. So again, rotavirus, Salmonella, and E. coli, and followed by PDB is the most common pathogen that we observe in enteric diseases. For finisher pigs, Lawsonia probably the most prevalent, and Salmonella is follow the trend as a causative of enteric diseases. When we look at the number of cases that we detect associated with Salmonella, I'd like you to see this trend. So we were looking at the number of cases from 2003 up to 2013, and the number have almost duplicated. It's a double of number of cases with a random pattern. So we don't know at this point if this is associated with the use of antibiotic, but certainly the number of Salmonella cases is increasing over the years. When we look at the type of Salmonella we found more frequently, Salmonella typhimurium is, of course, the most prevalent, followed by Salmonella derby. Typhimurium Copenhagen is the most prevalent, followed by derby and typhimurium. So this historically had been the most common Salmonella type affecting pigs in the grower finisher stage. The other Salmonella that I would like to see associated is Cholera suis. Cholera suis is not commonly associated with enteric diseases, but rather cause systemic infection. And in the totally opposite what we see with Salmonella enteric, that the number of cases is growing, Salmonella cholera suis, the systemic version, is reducing over the years. So we don't see cholera suis that often as we used to do before. When we look at the antibiotic resistant pattern, you may think that antibiotic changes over the years, but the truth is that the percentage of resistancy of the antibiotic that we commonly use haven't changed a lot for the last 10, 15 years. So we were with, I would say, gentamicin in 80% and now 90% resistant. So that change in 10 years is not that much. For the other common antibiotic, chlortetracycline, ampicillin, it's still about the same resistant pattern. So why those changes in the number of cases, we don't know, because the resistant patterns is still about the same. Now, this is a totally different section. I put it then under systemic diseases, but mostly what it is new discoveries that we are doing in Iowa State associated with other universities and new diseases that we are dealing with. So let's start with PCV3. To make a little historical reference about PCV3, when for years we've been dealing with PCV2. So PCV2 had been always associated with this post-weaning wasting disease or nephropathy syndromes in sows. So, but the truth is that with nephropathy disease in sows and abortion, no one ever could reproduce the disease. So pigs have been infected with PCV2 and the disease never really been replicated. So what we found in this case is that cases that present with the typical cutaneous lesion and abortion had a high prevalence association with PCV3. This is the case where we found it for the first time, and this is the lesion that we normally see, that we used to think that was a PCV2 type of deal. So these cutaneous hemorrhage that go in the ventral region, they go the hind limbs, and abortion. So these two were the common pictures that we used to say, yeah, it's a PCV2 type of deal. No, now we found that most of these cases have also PCV3. So the cause association has not been established yet. We are working in that part, but at least we can say that this virus had been detected in this type of cases. This is the structure of the virus, quite similar to PCV2, so there is no major difference what we know about the viral structure. So this is gonna help us to probably advance in the study of the disease because we have already in place a model that we use to study PCV2 over the last 10 years. So this is what we have learned about PCV3 in the last year or so. Another new disease, actually the disease is not new. We all probably heard about shaking pigs or dancer pigs for quite a long time. Now we can make a cause association. We finally found the cause of these shaker pigs. So Dr. Arruda in Iowa State, he was the first one describing the porcine pestivirus that caused congenital tremor or these dancer or shaker pigs. So the congenital tremor, what it is when the pigs are laying down in the crate, they are in rest, nothing happened, but when you wake them up, they start shaking. And the main problem with those guys is that they can't eat. They can milk, and they basically starve themselves. So the first description of this disease, as I said, it has been quite a long time. It's not a new disease. What we found is a new pathogen associated. And the prevalence is reported sporadically all around the world. So that is not something new in this day. So this is a picture of congenital tremor. So you have these pigs that are sleeping just fine, and when you wake them up, they start shaking. And associated with that, you have some spray leg as well. So this is the typical picture that we see in a shaker pig. For years, we suspect different causes. This is just a brief summary of what has been suspected as a cause of a shaker pig. So classical swine fever, viruses, you name it, unknown viruses, genetical association, sex-linked, genetical autosomal recessive disease, and trichroform. Those were probably the most common things that have been, even PCV2 have been tried to be associated with this congenital tremor, but no one ever really could reproduce the disease till now. So this is the first case that Dr. Arruda got. So this was a real shaker, no doubt about that. What was new about this is that he tried to isolate the virus. So he basically used this technology that I mentioned when we're talking about PRRS, the next generation sequence. So we got this fantastic tool that allows us to detect pretty much everything that is in the sample. So he was able to detect this new pestivirus. This is an alignment of the virus, so this is one of the protein, then C3 and the nucleoprotein, and it close related with the pestivirus. So they detect the virus, they isolate it, and the good thing is they put it back in a pig and reproduce the disease. So this is what they did. This is an ultrasound. They are injecting the virus there. You can see the needle going through the uterine horn. Can you repeat the thing? I like it. So this is the fetus. You can see here the heartbeat. This is the needle going through the uterine horn. They are doing the infection. This is the second trimester. And a few weeks later, this is what we had. A full liter of shakers. So this is the first real experimental reproduction of the disease with a pure isolated virus. So now we can say that congenital tremor is caused by a pestivirus. This is just a summary of his study. So when you put this virus in a sow, the prevalence is really high. Look at the number of piglets per sow, and look at the number of piglets that show the clinical disease. So 5 out of 8, 7 out of 9. So it's quite prevalent when you do an intrauterine infection. What do we have now to help our clients? So we have the tools now to make the diagnosis. And that's the whole benefit of this experimental disease. Now we know what to test. Is the most important thing. That we know what are the specific samples that we need to detect the pathogen. So we can do PCR based on serum, central nervous system, so basically spinal cord and brain. We can use heart, and we can use lymph node. So we are in the process to develop new technologies, but this one is probably the most accurate that we can use now to detect the virus. Another disease that you might heard about this quite a bit in the last few years, Seneca Virus A. This virus has been associated with idiopathic vesicular disease and neonatal mortality, both. I like this picture up here because this is the very first case that we got 2 years ago in the diagnostic lab. Actually, that was the case. They sent us this picture and say, could you please help me to figure out what is this? We have this show pig that had this coronary band, hyperemia, and this is now vesicle. That was it. From there, we got all the outbreak of Seneca virus. This is a case with neonatal mortality that we're going to talk a little bit, but this is what we were dealing for the last 2 years. So from the idiopathic vesicular disease is simple. When the disease presents, what you see is these vesicles that can rupture, cause disulceration, and 7 to 10 days later, they just heal and disappear. You don't see anything. Those lesions can happen in the snout, in the coronary band. Here's another snow vesicle, another lesion in the solar plant of the hoof. So the problem with this disease that based on the gross description, we can distinguish from any other vesicular disease, like foot-and-mouth disease, for example. So that is why it's so important to get diagnostic tools that allow us to differentiate this one from the other vesicular diseases. This is the neonatal mortality presentation. This is 2 liters. One not affected, the next liter is totally affected. So we see is this increment in mortality between 7 to 10 days post-farrowing, and that's it. We can't find anything else. We detect the virus, but we don't see lesions. We don't see any other pathogens associated. There's not a specific clinical signs. Some of the cases have been described associated with diarrhea, but we don't find a cause association with the virus and the diarrhea. So we basically see pigs dying, and we don't know why. So what tools do we have to make the diagnosis? So the clinical disease, when we have the vesicular disease, is easy to do it. So we rely in the gross description and clinical presentation. We also identify the virus. So we use PCR. This is just one example. How do we use the PCR? So basically we can do sequencing and serology with the historical virus that have been described for over 20 years with this new variant that we described 2 years ago. Another way that we use to do the diagnosis is this one, we label the virus in tissue. So we can get skin sections and use antibodies to do the viral identification in tissue. The molecular diagnosis help us to accomplish the first goal when the disease appeared, that was to understand the shedding pattern. We didn't even know how the virus was shed. So we just got a group of souls that were clinically infected, and we were seeing how long they were shedding the virus. So when we look at the serum, that was really, really short. The viremia lasted for 2-3 weeks, and that was it. But the virus keeps shedding for up to 6 weeks. So that means that the transmission, the risk of the transmission among sows and piglets is really high. When we look at the piglet from the same sows, the shedding went down in 4-5 weeks. So it means that in the later stage of the production, those pigs probably won't shed the virus, won't cause more infection. This is the case distribution that we see through the last 2 years. So this is a week report that we built up in our lab. Here in the blue bars is the sows cases, the red bar, growth finisher cases, and green bars are unknown. It means environmental, oral fluids, those type of samples. So if you see there is it's a pattern. It's a cyclical thing. And actually, it's fun. I was reading a producer report from the 60s, and they described this seasonal vesicular disease that happened during the summer. Of course, they didn't know the cause, but they described that every summer they have vesicles in the sow herd. So maybe we were dealing with this for way longer than we think that we are. So what is the serological prevalence? That was one of the questions that we had after the first outbreak, because it's easy to do the diagnosis when someone describes the vesicles, but what happens in those that we don't see the vesicles? So we want to know exactly how distributed it is. So we just finished up this preliminary study a few weeks ago. What we did is we collect samples from the last 6 months. So we just want to see one production cycle, so from July 2016 to December 2016. And this is what we did. Almost 2,000 sows and almost 4,000 piglets, and this is the prevalence. So almost 30% of the sows were seropositive, which means 30% of them were in contact with the virus. And all these samples came from farms that never, ever described clinical disease. They never saw a vesicle. The same thing for piglets. About 50% of grower to finisher piglets had been in contact with the virus. In those farms, no one described vesicles at all. We look at the number of farms that were affected. So 75% of these sow farms were affected. So it means that at least one of the farms at least has one positive animal during the study. Almost 62% of the piglets, the finisher farms were positive as well. Look at the distribution. So I just highlight where we are and what is our reality. So this is for the sows farms. So 12% of the sows in Iowa were in contact with the virus at least once. And this is what happened with grower and finisher piglets. So 70% of the piglets were in contact at least once with the virus during the last 6 months in Iowa. In summary, what we have learned about the Seneca virus, there had been an increment of this idiopathic vesicular disease that we didn't see before. There was an increment in breadwinning mortality associated with the presence of Seneca virus as well. We identified a new variant of this virus that is totally different from the one that had been described in the early 90s, and we finally determined the serological prevalence of this virus. There are a lot of questions to be answered about Seneca virus. So we see there's some viral mutation. We don't know the origin of this mutation, and we don't know if it is the cause of the new outbreak that we see clinically. The host pathogen interaction is also really important to understand. Predisposing factors, there's something that is triggering the disease, and it's probably a predisposing factor there that we don't know. I should probably cross the serological prevalence because it's something that we just finished, but we need to learn more about the viral prevalence and the clinical prevalence. There are farms that probably not reporting the disease, so we need to learn about that as well. Viral persistence in the environment and viral inactivation, I should probably cross that one out. There's just a paper came out from the University of Minnesota where they treat the virus with so many different disinfectants, and they found a really good result how to deal with the virus in the environment. So with that, I hope I covered quite a few things. We're ready to take your questions.
All right, thank you, Pablo. We'll have you and Dr. Main just join up here quick on the panel, and we'll see if there are any questions from the audience. Yes. So just to repeat the question, and the strains that you're talking about are the ones that Dr. Main showed on his graphs? So the question is, with all those different predominant RFLP, if we assume each one of those are a different strain, has there been any work to demonstrate that there's cross-protection between those different groups?
My guess is no. Yeah, that's on or not. These, I would just say in general, these, I don't know if that's on. You guys can hear me anyway? That's okay. So anyway, the gist of the question was about cross-protection, and I think you might answer that two ways. It's if you expose pigs and then challenge them to either field virus or the vaccine and said, well, where's there some cross-protection? And you would say, especially in the growing pigs, generally it's more obvious that yes, there's some cross-protection. But from a more clinical, to say, especially with these more highly virulent, it sure doesn't wouldn't appear grossly that there's lots of cross-protection. And I think that the word cross-protection is sometimes somewhat in the eyes of the beholder, but historically speaking, that the level of cross-protection observed that's in this historical growing pig model tends to be better than what's observed sometimes in the breeding herd. But I think with the two main clusters that I talked about, reality is that these are just very virulent viruses. And even maintaining immunity within a herd that has seen it before is not good at all. Not for very long. I mean, they're just highly virulent. So most folks in these breeding farms are not choosing to keep acclimating back, in many cases, just because it can be really, it's just these highly virulent viruses are hard to deal with, to keep them contained. It just doesn't work very well.
Pablo, do you want to add anything?
Yeah, regarding the cross protection is what you look for. If you look at clinical protection, it's something totally different than just immune protection. We build up this prototype vaccine where we kind of combine all the strains together, and we can generate antibodies that are going to neutralize a broad spectrum of strains, and that's okay. But when you go to a clinical trial, the lesions are still there. So you get antibodies. So technically you're getting cross-protection because you are generating antibodies against a lot of strains, but the antibodies are not enough to prevent the clinical disease. So that's probably something that we need to think about. What is the definition of cross protection that we're looking for?
That's a good way to explain it. All right, any other questions? Yes, Drew.
Pablo, you may have covered this. I didn't catch all of this, so forgive me if you covered it. But with Seneca A, what are the packers, how are they responding to this kind of uptick that we saw this past
No, as far as I know, what is happening is all the positive cases are being rejected. I know that there's been some adjustments in places where they get specific days for slaughter, but probably
Yeah.
you can
So I
add-
think I can speak to it a little bit, is just because, like Pablo was saying, is we've been, I think I had a slide the other day. We've had roughly the last 2 years, the summer from 15, and then in this year, we've had about 100 of what we call vesicular disease-related foreign animal disease investigations. Okay, and what that means is, because when these vesicles are observed and people see these, coronary band lesion or vesicles on the nose, is that, by rule, so to speak, that those are to be reported. And the reason is because you can't, it's around, you can't visually determine a difference between foot and mouth disease and this Seneca Virus A. And that's both on farm and in the slaughter chain. And what we saw a lot this summer was animals showing up at slaughter, hadn't been reported or observed necessarily on the farm, but then they show up at slaughter and they're observed, and it's a huge issue, because what happens is they won't let any pork move out of the plant until it's been cleared. Okay, and so what happens is the state VMOs have to collect the samples from the pigs at the plant,
Right.
and then get the samples curried to the lab, and then we have to and then we test them and report the results. And until those results come back, they can't move meat out of the plant. They can still take pigs, okay, so they can still kill pigs and receive the pigs they're planning on that day, those kinds of things. But so it's very urgent, it's very significant, and so our role in it at the lab is to provide so basically what we do is we do FMD PCR and then the Seneca Virus A PCR simultaneously upon receipt, and getting those results back to the state and then to the plant in that case, or if it was on farm, to the submitting veterinarian, so they can resume. Because we've had the same thing both at the plants and then at sow farms, of course. Probably what has been most critical has been because they can't wean, right, until they get cleared. So same kind of deal. And so just the last two, and just for some context, I mean, we've had more of these vesicular, since the reemergence of Seneca Virus A, we've had more FAD investigations the last 2 years than we would have ever had, in history. Like historically, maybe a couple, 2 or 3, and now we're doing over 100, a year. So. But and then the other, Drew, point your question on the deal about the sows, okay, and so that's what was coming out, I believe, out of a plant in Wisconsin, and what they were doing there, they were having to do is, and again, this is what just I've been told secondhand, because we haven't been the ones doing it, we've been the ones doing with the finishing pigs, but as I understand it to be, they're still running the same rabbit for the FAD investigation, because that's required and so on. But they were not, I think they might have euthanized the sows, and then they were not paying the customer for those sows. And that was a way, because, it's a major headache, and I think in what happens in the sow world, which is different, and Chris and these guys have done some really good work on that, has been, some of these sows are in the chain, the slaughter chain, for significant periods of time. You know what I mean? You can get a sow that, she may have been, sometimes a week, and sometimes more than that, on extreme. And so what can be happening is these sows are getting exposed, naive, or less immune sows are getting exposed when they're being commingled at, say, a buying station somewhere, and then, but if they're not, shipped to slaughter right away, it gives the virus time to
Right.
incubate and so on. And so that was their way of pushing it, trying to get people's, I think, attention of, this is a major thing, so look at your sows before and all of that. But I think in large part, the stuff in the sows, it necessarily wasn't that maybe those lesions were present at the farm. It was just that those sows were in the chain, the slaughter chain for a while. So, One other thing I would say that's interesting, and Pablo has been involved, and Chris, with a gentleman, Daniel Linares, another colleague there at Iowa State, and one of his graduate students named Marcelo Almeida, have been doing some work at looking at this prevalence at, prior to slaughter, at slaughter, and looking at, and so on, and what their initial findings have been, that when they go in and they do SVA PCR testing in the finishing barns by oral fluids, they can't see evidence of shedding, okay? And then they go and they sample those same pigs at the slaughter plant after, they've been loaded on a truck, stress, and then put together and all that, and they found the prevalence to be very high, okay? Mm-hmm. And so maybe like, Pablo was saying, is there some sort of cofactor or stress-related thing, that maybe brings out shedding? Maybe it's being harbored in the tonsil or something, and that's kind of what it feels like.
Well, actually, now that you mention it, nice study. There is a nice study from South Dakota group. They show that the virus hides in the tonsil. So they infected, they let them pass the clinical disease, and when they recover, that they're not more clinical for a while, they put them down, and the virus is still in the tonsil. So that's probably part of the pathogenesis that we don't.
Who do I call if I see vesicles? Because I don't know, if I'm Joe Pig Farmer, I'm not too pumped up about telling someone I see vesicles. I don't want to be the guy who reports FFP in the U.S. Is it your vet? Is it your packer?
Right. So the deal is you would report it to your veterinarian, your herd veterinarian, okay, and then they in turn contact the state, okay, and then based on the situation is that either the herd veterinarian will collect the samples and submit them based on location, time of day. These things are always Friday night, seems like. Yeah, right. And then get them curried to the lab, and so that's one thing that we understand the impact and all of this, and so at the lab we do our absolute utmost to get these things turned around. Okay, so it's all same day, next day. If they're come in late, maybe we'll run them overnight, things like that, because we understand, because it's very important that the person or entity not only, so there's two issues there. One is because it's impacting continuity of business, right, to keep that moving. And I would say in Iowa, we're very, very blessed. We have a very competent and strong state veterinary staff, okay, and very, what I would say, practical, very producer-friendly and so on. And so what they're doing is they're letting the animals move and the pork move based on our results, okay, because for a lot of those FAD investigations, because of federal rule, they're splitting samples and sending those to New York, to Plum Island, okay, to FADL as kind of a backup test. But the state in Iowa is letting everything move on our tests. So we're trying to make sure we're giving the submitters a good experience, so because the worst thing that could happen is, people have a bad experience and then I'm not going to report it next time. You know what I mean?
Yep. Good question. Other questions? All right, I've got a couple. Pablo, for porcine parainfluenza virus, is there a vaccine or anything that we know that may work against that?
No, we don't. Actually, as I said, we don't even know if it is a primary pathogen. We are finding this pathogen associated with just upper respiratory disease. The problem would be that this virus can set up pigs for a secondary. Bacterial infections or other type of, but no, so far we don't. We don't have any vaccine to prevent PPIV infection.
Okay. Very good. Other questions? Yes.
Veterinary diagnostic labs on the site, how long is that in or how much lobbying?
Right. Yeah. Stop by on your way by. I don't know. So it's a very significant effort. There's, as I mentioned in the slide, as it's being proposed today, that there's an ask of $100 million, okay, from the state and $20 million from private and university funds, okay, and so it's very, very significant. And how the process works is that we are on the top of the Iowa State Capital Project ask, okay, and amongst the regents, one of their infrastructure asks, okay, and so, and how it works is that at the end of every as they near, it'll be talked about, it'll be proposed by the regents this spring, okay, to the legislative session, and then the legislators will look at that project as where does it fit in their, in priorities, in funding available, and things like this, okay, and then so ultimately those decisions will be derived by the legislators of the state of Iowa. Yep. So what it's being looked at is that a standalone facility on the CVM campus. So the same complex, but a standalone a building as opposed to where we are now. But it's a very significant undertaking for the state to consider.
Any other questions? I've got one more, last one for Dr. Pineyro, and it has to do with PCV3. Do we know anything about, do the current PCV2 vaccines protect against PCV3?
No, we don't. We know that the capsid, the structure is quite similar, but we don't know if it is any cross protection. So actually, we're going to start in 2 weeks pathogenicity study. So we might try that.
Might know
but
more.
we don't know yet.
Okay. All right. Any last questions from the audience? All right. Help me again to thank our two presenters today.